Okay, so this is Wednesday's video for March the 15th, naming compounds with monatomic ions and writing compounds with polyatomic ions. So this one has two parts. We're going to do the second part of what we started yesterday, Tuesday, and the first part of then taking it to the next level where you're using those polyatomic ions. On the WebEx last week, y'all let me know that you would rather have your work posted towards the beginning of the week and then just have it dated, and then you can work on it as you want to throughout the week. So that's what I'm trying to do. Granted, it's Tuesday and I'm just now getting to it because of the power issue at my house yesterday. But let's go ahead and get started. So this is the problem we did as an example yesterday. So I'll write these formulas. Actually, let me not write it like that. Let me write it little bitty so I've got room for names too. So this was Mg Cl2. This was MgO. This was Al Cl3. And this was Al2O3. Okay, so when you're going to name these compounds, and these are ionic compounds, your video tomorrow will talk more about the difference between ionic and covalent, but for now know that these are all ionic. Okay, you're going to name them from the ion name, and these two snippets here are from the ion sheet that I attached to yesterday's post. So you do need to reference that to do this. So we need to find each of these ions on the sheet to see what their name is. So Mg plus 2. Oh my gosh, it's off the bottom of the page. I gotta do this so I can pull it up. There we go. There it is. Okay. Back to my highlighter. So Mg plus 2, that is magnesium. Al plus 3, that is aluminum. You're like, come on, Miss Garrison. Of course it is. Okay, but some of them are not. See these Roman numerals? We'll talk about those in a second. Okay, Cl minus 1, that is chloride. And O minus 2 is oxide. So these are not exactly what they are on the periodic table. It's not just the element name. Okay, so a rule you may want to jot down: negative ions name changes to end in ide. Very important, okay? So the name of this is not magnesium chlorine, it's magnesium chloride. And actually, I'm going to throw me a little text box in there, except I want it to be smaller text. That's probably good. Then get my keyboard. So this would be magnesium chloride. This one would be magnesium oxide, which has an X in it. This one would be aluminum chloride. And this one, you know what, I didn't pause it and have you, I didn't tell you to pause it and try them yourself. Oh well. I think this is pretty easy, so it's not that big of a deal. Aluminum oxide. Okay, so those are the names from the examples yesterday. So what you'll do today, you got the same chart. Now, yes, I know this is a whole bunch of boxes. It's like 66 boxes, I think. I only want you to do 20 of them. Okay, pick 20 of them. I would not do the hydrogen boxes because those would not be the proper names. Okay, we'll talk about why in a couple days. But any of the other boxes. Now, I do want you to notice though, okay, anything that's a transition metal, so right here, cobalt +3, they actually can have multiple oxidation states. So cobalt +3 right here. So the name of that is actually cobalt 3. So if we come here to do this name, you actually have to say cobalt Roman numeral 3 oxide. Okay, because you've got to specify, is it cobalt +3 or is it cobalt +2? Okay, because when you write the name, you don't see the formula. And so if you're writing the name, someone's got to be able to then make that be a formula by knowing what the proper oxidation number is. Okay, the only one that's transition that does not apply to, okay, that is silver. Silver is only silver +1. Okay, so whenever you do those names, like this one, this is just going to be silver chloride. You don't have to worry about it being silver 1. Silver is always going to be +1. Always, always, always. Okay, and if you want to know why, quick sidebar. Okay, and I've done this with advanced, I know. Let me get my tablet back. Oh, it turned off. Come on now. No turning off. Maybe I turned it off. I don't know. There we go. So silver is 1, 2, 3, 4, 5s2, and then it is 4d9. This is silver ground state. Remember, we put all of our up arrows, and then we come back and put our down arrows. Okay, well, in advanced, we justified oxidation states. Okay, so to justify silver +1, which means it's going to lose 1 electron. Okay, well, what actually happens is one of these electrons is lost. The other electron comes here to make this be 4d10. Because that gives it a full lower shell, there's nothing in level 5, so it ceases to exist, and that's more stable. Okay, now, do the other ones in that same column do the same thing? They can, but they don't always. Okay, so that would also be copper and gold. They both can be +1, but they also can both be +2. Silver's the only one that is always +1. Okay, and it's just that magic size that's what works best for it, and so that's what it does. Okay, so again, you're going to pick 20 of these boxes, you're going to fill in the names, and then we're going to look at what if we have polyatomic ions. Okay, so polyatomic ions, let me get another little shot here, let me pause this. Okay, so I went and got that image. So I just want to, so this is the bottom half of that page I gave you yesterday attached to your document. These are common polyatomic ions, and what you should notice about these is all of these are more than one element that is existing together. Okay, it is not a single element like the monatomic ions that we looked at yesterday and then on the previous slides to do the naming. These are, I'm yawning, y'all. These are polyatomic ions, and so they exist as a unit, and they have a name that represents them as a unit. Okay, so we're not going to talk about the names so much right now. We're going to talk about how do we do the formulas. Okay, so your biggest rule here that you have to pull in is if a number is crossed down, it needs to be bigger. It's little. Bigger text. To a polyatomic ion, and then it made little letters again. If a number is crossed down to a polyatomic ion, parentheses must be added. What is this? That's 22. Let's do this. Let's go here and say 22, all of it. To show that there are multiple of the ion and not just a part of it. Okay? So, get my pen back. Pen, there we go. So here, we're going to look at the crisscross like we did yesterday. So we have NH4, and all of that together has a +1 charge. Again, the positive ion is written first. That's the purpose of the positive when we're writing formulas. N -3. Okay, let me change my color so you can see my different stuff. Grab just your number, cross it over. Okay, so we need 3 NH4s. Okay, so this is where this rule comes in. You have to put NH4 in parentheses, add the 3, and then write the N. Okay, so in this case, N is missing 3 electrons. It can get 1 electron from each NH4 because each NH4 has 1 extra. So it needs 3 of those to make it be a stable compound. Okay, so this is NH4, 3, N. Okay, at this point you need to pause this video. You need to try the other 3 boxes, and then you need to resume the video to see if you got them correct. Go ahead. Pause the video. Okay, so hopefully you paused it. Hopefully you tried them on your own. If not, you still can do that. But let's go on and do them. Okay, so then we have, keep this consistent, NH4 +1, OH -1. Okay, then we're going to grab just the numbers, and we're going to cross them over. Now, in this instance, it's a 1 and a 1, so no parentheses are needed, no new numbers are needed at the bottom. Okay, so it's just NH4OH. Okay, and if you'll notice, NH4, let me pull this back up. NH4 is the only positive polyatomic ion. The only one. There are lots of negative ones, okay, but that is the only one that is positive, is NH4. Okay, so let's pull this back down. Now, Al. So that's why I only have 1 as an example here on my chart. Okay, Al +3, N -3. Okay, we're going to grab just our numbers, cross them down. Okay, this one doesn't even have a polyatomic, so this is really a yesterday problem, but that's fine. Now, this would be a 3, 3. That is both divisible by 3, so you reduce it to the smallest whole number, Al, N. Okay, and then the last one, Al +3, OH -1. Grab just your number. Okay, so this time we do have a number crossing to a polyatomic. So that has to go inside the parentheses because we need 3 OHs. Even though it didn't have a little subscript here, that does not matter. It is more than one element, and we need 3 of the units. We need 3 OHs. Okay, so to get 3 OHs, we have to put that 3 outside the parentheses. If you left off the parentheses, it would look like it was 1 Al, 1 O, and 3 H's, which would not work. Okay, so make sure if you're crossing a number down to the polyatomic, you add the parentheses. Okay? You still will reduce 2 2s, okay, or 3 3s, or 4 2s, okay, to smallest whole number ratios. You would never reduce this 4 right here though. Okay, that's part of the polyatomic ion and it is protected. Okay, but if you crossed a number and had a parentheses, you could reduce those crossed down numbers. Okay, so post questions if you've got them. This is what today's practice looks like. It's in the document that's attached to the Google Drive, the Google Classroom post. Okay, it's not near as many as it was yesterday. So these are the ones for you to try. Then tomorrow we will name those and we'll talk through some general notes on bonding. I think is what my plan is. We'll see whenever you get the video if that's what I did or not. Okay? Talk to you soon.